This paper was presented at the JCT Traffic Signals Symposium 2023 in Nottingham, thanks to the support of AGD Systems, INRIX, Message Maker Displays, PTV Group, Simplify Systems, smartmicro UK, and TRL Software.
Thank you very much, everyone, for being here. My presentation, as mentioned, is overcoming bridge-mounted detection. I wanted to start off by sort of asking you all a question, which is that how often have you come across a site whereby the constraints have not allowed you to install conventional technologies? What hopefully my presentation will show you is how we, in one such site, have overcome it using our UMR11 Type 45 radars. I'm conscious of time, so I will try and keep this brief. So obviously any questions we've got, I'll stand outside afterwards. Please feel free to come and find me. So the site itself, this is the A48 Briton Ferry Bridge that you can see here. It runs over the River Neath and is located as a part of the South Wales Trunk Road Association down near Port Talbot. So as a way of a bit of site history, I won't read out all the points here, but suffice to say that the predominant challenges sort of faced on this site itself was a very shallow bridge deck of around sort of 30 to 40 mil, and also prone to sort of heavy fog, which should come up in another slide there. But the bridge itself is quite heavily used, especially when roadworks or indeed closures are put onto the M4, and that causes quite sort of difficult conditions for the signalised parts of that bridge to operate in. The map here shows you the actual site itself, and this is taken from the consultants 2014 when the site was first upgraded to MOVA. What you'll see is the site is actually split down into two. You've got the Briton Ferry site at the bottom here, and then the Earlswood site up on the left-hand side of your screen there. Although they're numbered Site 1 and Site 2, we actually approached Site 2 first, as the detection deterioration there in 2023 meant that there was quite a severe impact to the road network user in that location. So we actually ended up doing that as our first site. But sort of coming back to 2014, as I mentioned earlier, what were those what were those challenges that they faced? We've got sort of 8 points noted up there, which you can read through in your own time. But again, to highlight the fact that sort of 30 to 40 mil depth, very little knowledge of the bridge construction itself was available, so the civil drawings, etc., weren't available. And also the weather, the River Neath brought with it, especially in the winter time, an awful lot of fog, which made detection obviously there very difficult. So 2014, the consultants themselves had obviously a range of detection solutions that were available to them, most of which we've written up on the slide here. And next to each one of them, unfortunately, the reason why they weren't actually able to be implemented onto that junction itself. Again, I won't go through all of them, but one thing I will highlight is that the very last part of that slide there is the option to do nothing was not available. Something in that situation had to change. So what did change? In 2014, the consultants themselves worked alongside a company that produced wired magnetometers. And it was suggested that by mounting the magnetometers adjacent to the live carriageways and mounting them above the surface, so as to not have to, as I said earlier, penetrate the carriageway or indeed implement new ducting, they were mounted, as you can see here in the image. The consultants themselves and the customer, SWTRA as we know them, or the South Wales Trunk Road Association, were in a position where they said, actually, this is the best option we've got. So decided to go ahead and implement that around sort of, as it says there, August 2014. Was it a success? Initially, again, as you can see on the slide, initially for lane 1, the detection was believed to be very good. Lane 2, unfortunately, for the driver behaviour was meaning that detection was sitting at around sort of 50%. But again, that combination of the challenges that were present at that site and also the available detection technology at the time meant that the client and the consultants were happy with that level of detection, and it meant that MOVA could be implemented in a form for that junction. Unfortunately, from sort of 2014 onwards to 2023 or this year, the detection deteriorated up until the point that there was basically a complete loss of detection at the end of 2022 stroke early 2023. So that brought us in. SWTRA approached Centregreat, who we had worked with previously, who had seen our technology operating in other local authorities, and asked us to take a look at this junction and see whether we felt that we had a detection solution that could answer that question. And that we did. We got the site drawings. We did a bit of a survey, and we decided to choose our UMR 11 Type 45 radar. Again, there's some information on the screen there which highlights a few sort of key points about it. And I'm aware that, again, we've got short time. A lot of people know our product and how it operates now. So some of the key elements to it were that it allows the detection to happen out at 120 meters, which was due to the speed of the road, what the MOVA validation required, and also that it works in most weather conditions. I say that because I know there'll be some questions from someone somewhere about weather conditions. But fog and mist particularly, our radar works well in. Bit more about the radar itself. Again, these are on display outside, so if you do want to come and see them. But we have the serial relay option, which is the furthest left there. What that does is that takes the point cloud data that the radar sees, and it interprets that data as it sees the vehicles travelling over the virtual zones. It turns those into physical relay outputs, much like a conventional loop in the ground. You have the radar head as the next image itself with a CRO attached. For a bit of context, that Type 45 radar is probably the same size as a coaster that you get in your house. Obviously, don't store drinks on them, but the picture then next to that is our radar mounted onto our stainless steel bracket. The stainless steel bracket just allows us to maneuver and adjust the radar through both elevation and through azimuth on site or angle on site to make sure that we can get that aligned and that detection working as well as possible on that site. So that brings me on to the actual installation itself. The Type 45 radar was mounted onto the primary signal pole, which I believe was a crank pole at 4 meters. On that junction. Once we set it up, it took us around sort of half a day to set it up and to fine-tune it. We managed to use existing cabling that was present at that pole and programmed the radar and sat and fine-tuned it. And as I said, got our in-loops and our X's fit for purpose and operating very, very well. Post that, we sort of a couple of weeks later, came back with Matt Williams of JSDSM and conducted the validation. A few changes to loop positions and stuff were made to benefit Matt and how he sets up his MOVA data set, but very successful results from the end of that. What do we use to actually set the radar up and program it on site? So this is a screenshot here actually of that site itself, so the Earlswood interchange. And this is our TMC, or our traffic management configurator. This is the software that controls what the radar is seeing and how it's outputting its data. It uses a Google Maps overlay to obviously help us decipher where the lanes are, where the loops should be, how it sees the traffic coming in, and that can be replaced by using, if you've got a new site, for example, you can use scaled drawings in there, but we just used the Google Maps overlay in this instance as it was nice and accurate. You can see the coloured beams there. Again, it will be a question that I'm sure somebody will ask is what's the meaning of the beams there? And we have the red, the cyan, and the green, which are the most evident, and obviously the blue in the background there. And they're just for the different levels of classification for the radar, so the accuracy of classification in the red for cars, and the cyan for bicycles, and then in the green for pedestrians. Although you would hope not to see too many pedestrians on this road. But as you can see in the image itself, the in-loop sat at 120 metres from the stop line being sort of right next to where the radar is positioned in the yellow there, falling well within that red beam for cars. How am I doing for time? Doing all right. So moving on from the Earlswood interchange to Briton Ferry. So that was obviously, as I said, validated by Matt Williams and was successful and very happy with that site. About a month or so after that, we then moved on to install the Briton Ferry side, which we actually undertook with Tom Siddle, who I believe was here at some point today, from Four Ways Consulting, on the other half of the bridge there. All of the same challenges still applied. So the shallow bridge deck construction, the fog, the fast-moving traffic, all of these challenges were still very much present there, and so it's a very, very similar install in a lot of natures. However, this one we hit a bit of a glitch. The beauty of our TMC software, which you saw in the overlay here, is that we can dial in and assess these sites remotely. So prior to us actually arriving, we can build the plots, as we call them. We can place the radars, we can place the lanes, we can place the zones. We can make sure and understand that that junction is viable and suitable for us to actually implement our radars in. And taking a look, and you'll see in the slides to come that the actual position that we chose for this radar initially was a 6-metre pole. The reason we chose a 6-metre pole was that was what was available at the time, but it also worked very well because of the decline that the bridge had down towards the signalised part of the junction. And upon arrival there, unfortunately, the base around the 6-metre pole had deteriorated quite a lot, and it meant that we weren't actually able to get the MEP in place without, unfortunately, having to put a lane closure on, which, as we all know with a high-speed road, trying to put lane closures on is a bit of a nightmare. So the TMC again kind of came to our rescue, really. So it's put us into a bit of pain to start off with, but actually came to the rescue. We were able to, on the fly, speaking with Centregreat, also with the customer and with Four Ways, we were able to decipher that we could use another pole that was adjacent. It would still cover the loops, and it still gave us very good line of sight to the detection points that we wanted. So as I said, the TMC software kind of put us in the pain, and then also managed to get us out. So it shows us that degree of flexibility that we've got with our detection. You don't just have to put it up in a pole and hope for the best. Obviously, if it goes wrong, you've got days wasted with engineering time and potential traffic management implications. We were able to check the new pole, make sure the cores were there, the cabling cores were there that we needed, and check that it was fit and suitable for purpose and that we could access it properly. Luckily, all of those were ticks in the box, and we were able to stick that up there. very much the same sort of layout, so 120 meters on the in loops. Once we installed that, I believe that was the same day we installed it. So turned up in the morning, put the radar up. We were done by sort of 1, 2 o'clock, which I think was the point in which Tom turned up and came and did our validation. And thankfully, again, it's a nice successful validation showing good detection over that bridge deck. So again, this is our plot from that site. You can see that was the original pole, whether the laser pointer works here. This was the original pole that was used during the design process, but unfortunately there was a mixture of sort of concrete with grass growing over the top of it, which had deteriorated, meant that the mute wouldn't level, and therefore the bucket wouldn't raise. And then we ended up actually using a pole down in the cross-hatched area here, which meant there was no need for TM requirement. We could literally circle around the roundabout, get up there and put that up, and still managed to get very good detection, as I said. So just to sort of finish me up, I realise I'm coming up to the end of time here, but it's good because it means I don't get as many questions. We'll show here both of these two junctions, so the Earlswood interchange being on the right-hand side here, and the Briton Ferry being over on the left-hand side here, being on the 6-metre mast. What you can see is that both of those are very similar setups, so both Type 45 radars, again, being able to show that we've got that flexibility to be able to overcome the sort of obstacles that we faced on the ground, which meant, you know, less engineering time, less cost, and hopefully a happy customer at the end of the day. So I've raced through that a bit, but hopefully that's me covered everything. I'm sure my director will watch this back and tell me that I haven't, that I've missed lots of pieces, but that's me. Thanks very much.
Thank you, Charlie. If you do ask questions, he might make you do burpees, but are there any questions? Okay, can we get a mic in the middle to Tom, please?
Tom, to be honest.
Maybe he wasn't happy about his
yeah, I know.
the name
I know
drop.
the mention. Yeah, sorry, Tom, I didn't tell you.
Tom Siddle, Four-Way Consulting. Not really a question, really, because obviously, as Charlie said, I was involved on this project, but also with my former hat on at Atkins, I was involved with the original project, indeed standing up at the front, presenting this at the symposium. I was going to say, comparing the original technology, which was the best we could find at the time, with this sort of product from SVS, smartmicro now, it was far simpler, far more flexible, worked perfectly well. And as Charlie said, I sort of rocked up at lunchtime, quick check, test, validated it, easy peasy.
Thanks very much, Tom. That sales position is still open as well, by the way.
Any further questions? Well, thank you, Charlie, and thank you to all the other speakers. John, I don't know if you want to announce the break, but yeah, thank you, Charlie.
Thanks very much.
And thanks to all the speakers.